Here we have the problem from functions for IPE. Find the domain of the following real valued functions. F of x is equal to 1 by 6x minus x square minus 5. First problem. So here we have to find the domain of the given functions. So here first problem, given f of x is equal to 1 by 6x minus x square minus 5. If this value is 0, then it is infinitive. So domain is infinitive. So we take here 6x minus x square minus 5 not equal to 0. That is minus x square plus 6x minus 5 not equal to 0. X square minus 6x plus 5 not equal to 0. This is x minus 1 into x minus 5 not equal to 0. So what is the domain? Domain x belongs to R, all real numbers except 1 comma 5. So what is the domain of this function? F of x domain, x belongs to R excluding 1 comma 5. If you give 1 comma 5 values, then it will be 0, then it will be 0. This is 1 by 0. 1 by 0 become infinitive. So that's why all real numbers excluding 1 comma 5 is the domain of the given function. Okay, all of you, that's all. Here we have the given function f of x is equal to, second one, f of x is equal to root over x square minus 1 plus 1 by root x square minus 3x plus 2. Here you take first this function x square minus 1 greater than or equal to 0. So x square minus 1 greater than or equal to 0, that is x plus 1 into x minus 1 greater than or equal to 0. So what is the x belongs to? X belongs to minus infinity to minus 1 closed union. This is 1 to plus infinity. This is the domain of this function, root over x square minus 1 function. Again you take this domain x square minus 3x plus 2 greater than 0. So what are the factors of this one? X minus 1 into x minus 2 greater than 0. X minus 1 into x minus 2 greater than 0. So this is x belongs to closed interval minus infinity to 1 union, that is 2 to infinity. Minus infinity to 1 union 2 to infinity. The combined domain of these two is, this is the first one domain, first function domain, this is the second function domain. So what is x belongs to? X belongs to minus infinity to minus 1 closed interval union, you take this one 2 to open interval 2 to infinity is the, sorry, this is up to 1, okay, minus infinity to 1 union 2 to infinity is the combined domain of this function. Okay, all of you, that's all. Next, third one. Here third one is what? Third one, f of x is equal to 1 by root over mod x minus x. So here you see, all of you, 1 by root f of x function is there, f of x greater than 0. So mod x minus x greater than 0. Mod x minus x when it is greater than 0, that is x belongs to minus infinity to 0 is the minus infinity to 0. If x belongs to minus infinity to 0, then it is, this is implies mod x greater than x. Mod x greater than x, then x belongs to minus infinity to 0, then it is the domain of this function f of x. Okay, all of you? That's all. Here we have the fourth problem. F of x is equal to root over x plus 2 plus 1 by log 1 minus x base 10. So for this function, so if root f of x is there, f of x greater than or equal to 0. That's why x plus 2 greater than or equal to 0 implies x belongs to this is minus 2 to minus 2 to infinity. X belongs to minus 2 to infinity. Okay, all of you? So, here, this one you take. Here, 1 by log f of x is there. This is implies f of x greater than 0 and f of x not equal to 1. This is the condition. Here, this condition is this one, and here, this condition is what? F of x greater than 0, f of x not equal to 1. That's why this function 1 minus x greater than 0, minus x greater than minus 1, x less than 1, x less than 1. That is x belongs to minus infinity to to 1 open interval. Then combined domain. This is second domain, this is first domain. So x belongs to you can take minus 2 to 1 open interval and where x not equal to, if x not equal to 0, x not equal to 0, this is not equal to 0, x not equal to 0, you take, this is the domain of this function. Okay, all of you? That's all. Thank you. Here, fifth question. F of x is equal to root 3 plus x plus root 3 minus x by x. So, here you see fifth question. What is fifth question? F of x is equal to root 3 plus x plus root 3 minus x by x. Here, root over f of x implies f of x greater than or equal to 0. That's why 3 plus x greater than or equal to 0. So, x greater than or equal to minus 3. X greater than or equal to minus 3, and this is 3 minus x greater than or equal to 0. This is x minus x greater than or equal to minus 3. X less than or equal to 3. X less than or equal to 3. X greater than or equal to minus 3. So, here where x belongs to closed interval. This is minus 3 comma 3 or closed interval minus 3 comma 3. If x is equal to 0, it is not divisible. So this value is infinite excluding 0. Okay, or you can write this is x belongs to closed interval 0 to 3, minus 3 to 0 union. This is 0 to 3 closed interval. So this is also domain. X belongs to closed interval minus 3 comma 3 minus 0 excluding 0, or x belongs to closed interval minus 3 comma 0 open interval union open interval 0 to 3 is also domain of this function. Okay, all of you? That's all. Here next problem, f of x is equal to root over 4x minus x square. Here root f of x is there, implies f of x greater than or equal to 0. So 4x minus x square greater than or equal to 0 implies x square minus 4x less than or equal to 0. So x common, x minus 4 less than or equal to 0. Implies x less than or equal to 0, x less than or equal to 4. X belongs to closure interval 0 to 4 is the closure interval 0 to 4 is the domain of this function. Okay, all of you. Similarly, you take this seventh problem. Seventh problem is what? Seventh problem, f of x is equal to root over x square minus 25. So x square minus 25 the greater than or equal to 0. X square greater than or equal to 25. X greater than or equal to plus or minus 5. That's why what is the domain of this one? X belongs to closed interval, or you take like this x minus 5 into x plus 5 greater than or equal to 0, that is x belongs to closed interval minus 5 comma 5. This is the given function. If excluding, if x is equal to 0, this is root 25. Root 25 is the imaginary number. That's why you take excluding 0. Or x belongs to closed interval minus 5 to 0 open interval union 0 to 5 closed interval. This is the also domain of this function. This is also domain of this function. Okay, all of you. Here we have f eighth problem. Eighth problem is what? F of x is equal to log of x square minus 4x plus 5. If log f of x, then here f of x greater than 0 you take. X square minus 4x plus 3 plus 3 plus 3 greater than 0. Means what? X minus 3 into x minus 1 greater than 0. From this, x minus 3, x minus 1 greater than 0, or x minus 1 into x minus 3 greater than 0. X minus alpha into x minus beta greater than 0, where alpha less than beta. Then x belongs to this is minus infinity to alpha union this is beta to infinity. By using this formula, so x belongs to minus infinity to 1 union 3 to infinity. Okay, all of you. So this is the domain of the function. Domain of the function. Okay, all of you. This is the domain of the function. Here the functions. Ninth problem, you see. Ninth problem. Here f of x is equal to log of x minus step x. This must be belongs to R, real numbers. So here, that means here log f of x implies f of x greater than 0. That's why x minus step x greater than 0. X minus step x is greater than 0. So this implies generally step x is equal to what? X plus in rational part of x. X plus rational part of x. So x minus step x. X minus step x is equal to, you can take into this side, minus rational part of x is equal to x minus step x. So we have only rational part of x. So that is domain. Domain is equal to r minus integers minus integers. R minus integers is the domain of log x minus step x. Okay, all of you? That's all. So next problem, 10th one. So 10th one is what? 10th one. That is f of x is equal to 1 by x square minus 1 into x plus 3. So here this one x square minus 1 into x plus 3 not equal to 0. Always x square minus 1 into x plus 3 not equal to 0. This can be written as a square minus b square x minus 1 into or x plus 1 into x minus 1 into x plus 3 not equal to 0. So domain of this one, domain is equal to, this is real number excluding minus 1, minus 3 or minus 3 minus 1, minus 3, minus 1, 1. If you give these numbers to this one, so this is 0, 1 by 0 is equal to infinity. So that's why x square minus 1 into x plus 3 not equal to 0. That is, this is not equal to 0. R minus, this is the real numbers. Domain is excluding minus 3, minus 1, 1 is the answer. Okay, all of you? That's all. Next question. Here, f of x is equal to 11th one. F of x is equal to 1 by log 2 minus x. This one belongs to R, real numbers. So, here 2 minus x greater than 0 and 2 minus x not equal to 1. If 2 minus x is equal to 1, log 1 is 0. So this is infinity. So 2 minus x greater than 0, minus x greater than minus 2, x less than 2. And here 2 minus x not equal to 1. That's why here this is minus x not equal to 1 minus 2, minus x not equal to minus 1, x not equal to 1, x not equal to 1, x less than 2. X less than 2 means what? X less than 2 means what? That is x belongs to minus infinity to 2, excluding 1, excluding 1. X belongs to minus infinity to 2. So excluding 1. So minus 3 is there. That is 2 minus of minus 3, 2 plus 3. That is log 5. Like this, minus infinity to 2 is the true. This is domain. Minus infinity, open interval, minus infinity to 2. My excluding 1 is the answer. Next problem. F of x is equal to, this is 12th problem. F of x is equal to 1 by root over x square minus a square, where a greater than 0. So here f of x, this one, x square minus a square greater than 0. X square minus a square greater than 0. If less than 0, it is imaginary number. Is equal to 0, it is the infinite value. That's why x square minus a square greater than 0. This is in the form of a square minus b square. That is x plus a into x minus a greater than 0. X minus of minus a into x minus a greater than 0. That's why x belongs to minus infinity to minus a, open interval, union a to infinity. This is the domain of the function. Domain of the function f of x. Okay, all of you. That's all. Here we have the problem. If f is equal to set of 1 comma 2, 2 comma minus 3, 3 comma minus 1, then find. So 2 into f, 2 plus f square, fourth one root f. So you see all of you, here f is equal to set of order pair 1 comma 2, order pair 2 comma 3 minus 3, order pair 3 comma minus 1. So here f of 1 is equal to 2, f of 2 is equal to minus 3, f of 3 is equal to minus 1. So here first we have to find 2f, 2 into f of 1, 2f, 2f, 2f means 2 comma 2 f of 1, and this is 1 comma 2 into f of 1, this is 2 comma 2 into f of 2, 3 comma 2 into f of 3. So this is equal to set of order pair 1 into what is f of 1, 2, 2 into 2, 4. Okay, all of you, 2 into minus 3, minus 6. Next, 3 into 2 into minus 1, minus 2. This is the 2f. Again, what is the second one? 2 plus f. 2 plus f is equal to 1 comma 2 plus f of 1. 2 comma 2 plus f of 2. 3 comma 2 plus f of 3. So this is equal to 1 comma 2 plus f of 1. What is f of 1? 2. 2 plus 2, 4. So 2 comma 2 plus f of 2. 2 minus 3, minus 1. Here 3 comma 2 plus f of 1. 2 minus 1, that is 1. This is what? 2 plus f. 2 plus f is equal to what? 2 plus f is equal to order pair 1 comma 4, 2 comma minus 1, 3 comma 1. 2f order pair 1 comma 4, 2 comma minus 6, 3 comma minus 2. Next, f square. Here f square. So f square is equal to order pair 1 comma f of 2 square, 2 comma f of 2 square, 3 comma f of 3 square. Okay, all of you. So this is 1 comma f of 2, f of 1, f of 1 whole square, 2 square, 2 square is 4. 2 comma f of 2 square minus 3 square, this is 9. 3 comma minus 1 whole square. So 1. This one is the f square. Next, root f. Root f. 1 comma root f of 1 order pair. 2 comma root f of 2 order pair. 3 comma root f of 3 order pair. Here you see 1 comma root f of 1, that is root 2. F of 2 is what? F of 2 is minus 3. Root minus 3. This is imaginary number. F of root 3 minus 1. Root f of, this is imaginary number. Only 1 comma root 2 is the root f. Root f. Root f. This is only real number. This is only real number. Root 2 is the real number. Okay, all of you? That's all.